Day 316 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 154, find minimum in rotated sorted array 2. The difficulty level is hard, but don't worry because you already know we're going to keep that solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Question says, suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums the array nums of integers 0, 1, 4, 4, 5, 6, and 7 might become an array of integers 4, 5, 6, 7, 0, 1, and 4 if it was rotated 4 times, and 0, 1, 4, 4, 5, 6, 7 if it was rotated 7 times. Notice that the rotating an array a of 0, a of 1, and a of 2 all the way up to a of n one time results in the array a of n minus 1, a of 0, a of 1, a of 2, all the way up to a of n minus 2. Given the sorted rotated array nums that may contain duplicates, return the minimum element of this array. You must decrease the overall operation steps as much as possible. All right, y'all, so let's go ahead and break this question down by looking at these examples so we can make sure that we are doing this question correctly. Now, the first thing we need to keep in mind is in this question, in this question is going to contain duplicates, which is which makes it the hard part, right? Because if we're doing a binary search and say we're looking at, say we have an array of integers that looks like this, right? Or say this array of integers, say we take this array of integers over here, right? Boom. So we take this over here. Say this gets rotated like this. Boom. Say it gets rotated to 2, 2, 2, 0, 1, 2, right? So say it gets rotated like this, and we're performing our binary search looking for the minimum. And we perform our binary search and we see that mid is equal to 2, and then the right pointer is also equal to 2. How are we going to know which half contains the minimum, right? Before in 153 or in find minimum and rotated sorted array 1, they didn't contain duplicates, so we would know automatically by our pointers which side or which half of the array the minimum was on, because say we had another array, say it didn't contain duplicates and it was like 4, 5, 6, say it was like this, 4, 5, 6, and then we had 0, 1, 2, 1, 2, 3. When we found the mid, we would know that this and the left would be 4, the right would be 3, so we would know that this half contains the minimum element. But when we're dealing with this problem now, we might find the mid, which might equal 2, and the right pointer would equal 2, so we would have no way of telling which way or which half of the array the minimum is. So in order to handle this, right, we're going to, if mid is equal to the right, then we're going to have to decrement right by 1, and I'll explain that more in the code. But let's go ahead and take a look at these examples so we can just make sure that we're doing it right. But hence in the name, find the minimum and rotated array, we're still just finding the minimum element. It's just this time it may contain duplicates, which makes it a hard problem compared to last time there were no duplicates. So in example 1, we have the input nums equals a array of integers 1, 3, and 5. Output is 1 because 1 is the smallest element in this array. Boom. Same with example 2. In example 2, nums equals an array of integers 2, 2, 2, 0, and 1. This time the output is 0 and 1. This time the output is 0 because 0 is the smallest element in this array, right? And sounds simple enough, but like I told you before, it gets difficult when we're performing our binary search and we're using our pointers and the mid is equal to the right. It's going to be hard for us to shrink our search and decide which half of the array to search. So let's go ahead and get into the fun part, y'all, the actual solution. Solution's not that difficult, as I'm sure you already are aware of, but we still are going to get excited about it because we're still going to be learning something new and doing a new LeetCode problem. So let's get started. Now, the first thing is we're going to declare our 2 pointers, or initialize our 2 pointers, a left at the start and right at the end. So in order to do that, we're going to declare a variable called left, set that equal to 0. Then we're going to declare another variable called right, and we're going to set that equal to nums.count minus 1. Boom, just like that. Now we need to start our search. So in order to do that, we're going to say while left is less than right. Boom, we're going to open up the brackets. Now, first thing we need to do is we need to find the mid. So in order to do that, we're going to say let mid equal left plus, open up the parentheses, right minus left. And then we're going to come outside of those parentheses and divide it by 2. Now, when we find mid this way, this allows us to, when we use this formula to find the mid, it allows us to avoid any overflow. If we just did it, say we just did it like this, that may cause some overflow. But, or excuse me, say we did left, not like that, but say we did it like this, left plus right, and then we divided that by 2. Right, that may cause some type of this way it will find a midpoint, but this way will find a midpoint, but it may cause some type of overflow. So when we use this formula like this and do the left plus right minus left divided by 2, it's going to avoid any overflow. So now let's get started. Now we're going to say if nums square bracket mid is, square bracket mid is greater than nums square bracket right. Boom. Oh, sorry, y'all. The bracket should come outside of that. Boom. So if the middle element is greater than the rightmost element, it means the minimum is in the right half. So we'll just say left equals mid plus 1, which will make our search a little easier. It'll shrink the space that we have to search. Boom. Then we could say else if, so this means we need to search the right half. Boom. Now we could say else if nums square bracket mid is less than nums square bracket right, then we know we need to search the left half. So in order to do that, we're going to open up the brackets and we're just going to say right equals mid. Boom, just like that. Now this is where the hard part comes in, or which makes the question hard, where we can where we handle the duplicates. So we have to say else if nums square bracket mid equals nums square bracket right, because we're dealing with duplicates now. So this may equal this. That's when we have to shrink or reduce the search space by moving the right pointer to the left. So we're just going to say right equals right minus 1. Now, once again, let me show you how this would work, because I feel like I didn't show you this part to begin with. But let's go back to our array, right? Say this was our array right here. It would be, sorry, y'all. Let me get it right for y'all. Excuse me, that should be a 1. So once again, say this is equal to this. Boom, they're equal, so we don't know which side or which half contains the minimum. But when let me get rid of this. When we decrement, so sorry y'all, this should be minus equals 1, or no, minus 1 is good. But when we do right minus 1, now right becomes 1 because we did right minus 1. So now the mid is 2 and right minus 1 is 1. So now we know that this left half, or excuse me, this right half is what is going to contain the minimum, because remember, at the end of the day, we're trying to find the minimum. So that's how we know which side or which half of the array the minimum is on after it's been rotated. Boom. So I just want to show y'all that example before we continue. Now let's continue because we're almost done. All we have to do is come right here and say return nums square bracket left. And that will return the minimum element found. So let's run it. Make sure it runs like it's supposed to before we submit it. And it's accepted, y'all. Look at that. So let's go ahead and submit this. See what that time complexity is looking like. Ooh, that's what I'm talking about. 0 milliseconds beats 100% of users with Swift, y'all. Those are some good numbers. Those are the numbers that I like to see. So before we leave, make sure y'all get one more look at the code. Not that much code. That's all it is. That's all she wrote. Read it, learn it, love it. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.